Now we're doing the receiver grooves. Now the receiver groove is all about, in the cylinder head, we put a stainless steel hoop. That hoop is machined into the cylinder head and then protrudes out of the cylinder head. When it protrudes out of the cylinder head, let me do it here. Here's the hoop and here's the receiver groove. It needs to push the copper head gasket into the receiver groove. So that's the receiver groove that we're making right now. If you want to know more about that, go to one of my videos on sealing in the boost, I think is that video, on my website or on my playlist on YouTube. I explain the gasket, I explain the hoops, I explain the receiver grooves. So what this is doing is, now every tool also is set up off of this tailstock dimension right here. So the machine knows the height of the tool. So the offset, why the absolute numbers up here, I'm probably giving you too much information here. The offset numbers are actual offset from where the tool position is here. So this would be 0. This is 0.
The main center line is 0, and we teach it off that height.
Right. So we know what the center line of here to here is. So we touch every tool off of here. It's like a gauge block. So CNC guys would know what that would be all about. So every tool is, yep, there you go. Every tool is set off, so we know exactly where this height is, so we don't even have to touch off this height to here because we've already resurfaced it. The machine knows what height this is, knows what height this tool bit is, and we just tell it we want this tool bit to go 15, 10, whatever depth we want, and it does it. Point blank. So it knows the bores. We've made the bores in the correct orientation, or the correct location. We've set our correct diameter of what we need the receiver groove to be. And now this is going to go in and just ring, and be done. So I'll show you that real quick. We're not going to bother putting the screen down because it doesn't throw chips real bad.
Still got about 50 to go. 50 pounds. 10.
Looks like, how deep is that? Doesn't look good. It probably looks like about 10, yeah.
It's just practice.
Yeah, this is just a practice, just to show you what's going on. It's not actually taking it to the correct depth, because correct depth here would be 15 to 20, depending on where I want it to be and what the protrusion is on the hoop.
This already had receivers in it.
And this already had the receiver grooves in it, so we're just practicing here, and it's just showing we're just getting trained on how the machine works, operates, and how to do it.
We'll let the machine run and skim cut, and then we can add in the program to achieve an accurate depth.
Yeah. So we can, yeah. So technically, we can do it either way. We can do it this way, where we resurface first and then do the receiver grooves, and then it does leave a little funny, yeah, it leaves a burr basically up here. Or we can program it to bore, receiver groove, and then come in and resurface. Or we can resurface, bore, groove, and then come in and skim cut it. Multiple different ways of doing it. So that is how we do the resurfacing. And now we'll go into lifter bores and how it does a lifter bore, which is it has a very nice tooling package for the lifter board. Let me show you the tool first, because I like the tool. So this boring head right here is a bad little ombre, and each tick in that turn screw is a 1/10 of a thousandth. So a full turn is 1/1000th, and each little tick there is a 1/10 of a thousandth. So that is very accurate for moving this little boring head tool bit out. So I like that. That is nice and relatively sure. That's not cheap, so we don't want to be crashing that bitch. Okay, so we're gonna bore just 2 holes and show you how this works. Now, this is currently, because this is aftermarket block, we know where the crankshaft center line is, we know where the camshaft center line is, we know where the dowel pin location is, which means we know where the bores are, where the cylinder head is at, so we know where the lifter bores go. There is a different way of doing it too that's really only available on the Rottler, and I'll let Marty explain that just real briefly because don't want to get hung up in the weeds.
If you're concerned about parallelism between the crank and camshaft bores and straightness, you can fixture the cam bore in the center of the 4th axis, taking that out of the equation. That's the way super stock, pro stock guys are doing the lifter bores.
So if your block was, you have the main tunnel perfectly straight, and if your cam tunnel was put in slightly off, me personally, I would make the cam tunnel perfectly straight and right, but you can actually fixture it in the cam tunnel. Now this is highly exaggerated, okay? I mean, you're talking thousandths, not very much. You can fixture it in the cam tunnel, and then the cam tunnel would be straight and parallel with the machine instead of the main tunnel.
Correct.
Yes. Don't get hung up on that, but it is all things you can do. So now let's go through here and we'll bore these 2 holes, and we're not going to bother boring everything here. I just want to show you how this works, runs through, and just it's nice. It's going to be super fast, and compared to, and the surface finish that's there is really nice too, which we'll just have to go through and just touch it with a hone just to knock off any high spots, and that's it. This has a pretty slow feed rate, so
Just plenty of clearance on the top side.
huh?
We're just got plenty of clearance on the top side, so it's coming down.
Oh, it still isn't. The tool bit hasn't come down yet. I think it's in there.
It's in there.
It's in there.
It's not cut.
Did you go the right way?
Probably went the wrong way.
Well, that's better than going the other
The
wrong
other,
way.
yeah. Way too much.
All right, so we're gonna reset that tool bit. So Mitch moved it out 5 thousandths, but he actually moved it in 5 thousandths. So now retract it nice and neat. So we'll go up here and turn that 80 feet little screw. So there's a set screw, and there's the adjuster that moves the head out.
See, I'm used to clockwise. It's counterclockwise to move this one out.
It's your story, Mitch. Tell it any way you want.
It's my story, and I'm sticking to it. There's 1, 2, 3.
So that should be just 3.
It's 6 thou, actually. It's 2 thou per revolution of that.
Oh, 2,000 per
Yeah.
revolution. My bad. Obviously, it doesn't have a spindle orientation for this procedure. It doesn't care.
Yep. At the end of the
Oh, it does. It does. Because it
Because
still wants. It still wants to move over. Okay.
You can turn that function on and off.
There we go. How much can you take off at a time on this tool?
About 30 is what I use as a maximum to not tear my tooling up.
Okay. So when we're doing oversized lifter bores, or like this was is a 904 lifter. So that'd be 842 to 904, so that's 60, basically 60,000, 62,000. So we do that in two swipes.
Yep. We do sell tooling if you're putting a bushing in to basically punch it out within 20 thousandths of your finished size. So you can rough it with an end mill first, and then just finish with the micro boring heads.
Yeah, so you're not wasting time cutting small amounts. Do you have the fixturing to work with the bushings? The installing the bushings?
You mean like a keyed lifter bushing?
The keyed lifter bushing.
So they do have an arbor that will push in and hold the spindle position for your keyed lifters for lifter bushing installation.
Yeah, that's been something why I've stayed away from a lot of that, and usually would have somebody else put in lifter bushings, keyed lifter bushings, because it's a mother. But so you can put that in, so they got an arbor that holds it in the correct orientation, and this has got enough beams to drive it in itself. That's right. So this thing's just about done cutting all the way through. There we go. And stops the spindle, moves the tool away, comes up. Very nice. Nice surface finish here. And that one's a nice finish right there.
Normally use a ball hone just to deburr the edges of the oil hole and so forth.
Yep, just use a ball hone, just run through there.
You can bore it to size and ball hone it just to deburr it and give it a little bit of cross after you want.
All right, now, so we wanted to experiment and see if Mitch has been paying attention and has learned what he's supposed to learn and can do this in a quick operation way, which we'll see. So we grabbed a stock 350 Chevy block. Very rare to even have. I think actually we had to buy a stock 350 block because we don't normally do these, but we just wanted to put that up there and just floor to floor. So we're going to show you that real quick here in time lapse. So you see how we did that? I think we had a grand total of about 2 hours from basically floor to floor. So put it in the machine, bore it 30, deck it down to our spec, which is 9020, and chamfer the top of the bores, offset cut the bottom of it, so complete, ready to hone.
Writing the programs.
Right.
And probing it,
Yeah, probing it and everything. So that's floor to floor. That's really nice. I like that. So now I'm going to show you the stroker clearance programming that it has, which is nice, and that takes this rougher, 1-inch rougher end mill and comes down here in an arc and will hit the points that we program it in to do stroker clearance. So it sends the tool bit on an arc like that, just like the connecting rod is swinging in the block. So I'll show you that real quick. And this would add, looks like it adds what, because we already have it programmed, already done for small block Chevrolet, probably adds what, half an hour total. So we could do a bore, deck, chamfer, all the processes there, even on the China wall, and stroker clearance in 2.5 hours total, with minimal time, operator time involved in it. So like that. So let's show you how this works real quick. You'll see it go down and sweep. since we're not cutting a whole bunch here, can you override the speed just so it'll go a little bit quicker for the camera? Not really. Okay. There we go.
It does have rapid but
Oh, it does do a rapid? Oh, okay.
So it's got another inch to go, and then it'll go rapid up to.
All right.
The China or the handrail side.
All right. Yeah, let's get that out of the camera. So kind of shoot it from like that angle, Kyle, or everything. It'll rapid here and then another half an inch. So the tool bed is actually going up and down, and yeah, it's sweeping. It's doing this. It's very gradual. You'll see it here in a second. It's kind of rapid.
Yep, it's moving on your Z and Y axis simultaneously.
Yep. There you go. You missed it. Oh, and camera operator Kyle missed it. That's all right. It rapided it over, so it saved a much time coming up into there. So now it'll come in, and it's still following that arc like this. So it's taking minimal amount of unnecessary material. You can show my finger right here. Right here. So this whole thing is a curvature. It's curved like this. If you can see it here, and look at where it's not cut here, to where it continues up cut. That little gap right there is going away. Oh, it feeds back down on the other side.
It's just going up. It's just going up is all. It's arcing up. You had a gap between there.
Oh, okay. Oh, I see.
100 to go.
There you go, and then it's going to automatically go over and do the other side. So, that's how the stroker clearance works on the F69. Very nice deal. Once it is all programmed in there and done, makes a super fast, quick way to avoid having to sit there and hand grind on stuff forever. So that's a real nice deal. Now we're going to be waiting for, they're just a little bit late on our line bore stuff, but as soon as we get the line bore stuff, Marty's coming back and going to train us on the line bore stuff. So Marty's going to take his cot with him, and so he can bring it back later and do training on the 90 or on that 90-degree boring fixture, which is I'm pretty excited about that because that's a really neat deal. And we have line honed blocks that we're going to run through there that are freshly line honed, so we can dye it, and then you'll be able to see exactly where the machine cuts versus where the hones to. Be interesting. All right, I'm Steve Morris. Have a great day.